Airspeed indicator. Airspeed indicator uses both static and dynamic pressure, and the principle is dynamic pressure. It uses dynamic pressure mostly, but within the instrument will be having both static and dynamic pressure. See, in airspeed indicator, I'll show you the diagram. This is an airspeed indicator. Here we will be having a pitot tube, and here we have static vent. Through pitot tube, both dynamic and static pressure enters. Through static vent, only static pressure enters. When static pressure enters, this static pressure and the static pressure inside of the capsule gets deleted, and we are left with the dynamic pressure. So this way we were only left with the dynamic pressure, and the indicator, airspeed indicator, uses this dynamic pressure to indicate the true airspeed. What actually airspeed indicator does is it shows us the true airspeed within ISA conditions. Now ISA conditions are as follows: pressure of 1013.25 hectopascals, temperature 15 degrees, density 1225 gram per meter cube, and near MSL, at MSL, mean sea level. Now we have different types of airspeeds. The first one is indicated airspeed, and when it is corrected for pressure error, I mean if from the indicated airspeed, if we delete the pressure error, we'll be left with calibrated or rectified airspeed. Now if again calibrated airspeed is corrected for compressibility error, we'll be having equivalent airspeed. If equivalent airspeed is corrected for density error, then we'll be getting true airspeed. Further, if we correct true airspeed for wind component, we will be left with ground speed. Now there are some V codes within the airspeed indicator. The first one is VSO, stalling speed at landing configuration, and then VS1, stalling speed at clean configuration, or clean configuration is nothing but when the landing gears and flaps are being inside, I mean retracted. When the landing gear and flaps are retracted, then it is called clean configuration. VFE, flap extension, maximum flap extension speed. VNO, maximum normal operating speed. VNE, maximum never exceed speed. VLO, maximum landing gear operation. VLE, landing gear extended. And again we have Vy, which is rate of climb, and Vysc is nothing but rate of climb for single engine, and Vx is angle of climb. This is how the indicator dial is represented. Here we have VSO, VS1, VFE, VNO, VNE. Now from VSO to VFE, we call this as white arc, and from VS1 to VNO, this is called green arc, and from VNO to VNE, it is yellow arc. Lastly, VNE, near VNE will be having a red arc, and again along with these we'll also have blue radial and red radial within the dial. So as the dial was shown, here we have ASI arcs and ASI radials as well. So white arc indicates from VSO to stalling speed at landing configuration to flap extension speed, and green arc, stalling speed at clean configuration to normal operating speed. Yellow arc is from normal operating speed to never exceed speed. Red arc is never exceed speed. And radials, blue radial VYSE, rate of climb for single engine, and red radial VMCA. Now we have different kinds of errors in ASI, and we can recognize them as blip DCM. Just remind them as blip DCM: blockage, leakage, instrument, position, density, compressibility, and maneuvering. Now blockage error. If pitot tube is blocked during climb, it overreads, the instrument overreads. First of all, what is overread and what is underread? See, for suppose you are flying at 1000 feet, okay, but your instrument is showing 1500 feet. If you are flying at x value but your instrument is showing some x plus 2 or x plus 3 value, I mean the value which is shown more than it is called overreading. And underread is nothing but if you are flying at 1000 feet, for example, but your instrument is indicating 900 feet, that means the instrument is underreading. If we were left with not the correct feet, not the correct altitude, but if it is showing the lesser altitude than we were flying, then it is called underreading. So if the pitot tube is blocked during climbing, the instrument overreads, and pitot tube blocked during descent, it underreads. As well, if the static vent is blocked during climbing, underreads. And if the static vent blocks descent during descent, it overreads. Remember this table in this way, it helps us. Then we have leakage error. If we have pitot tube leakage, the instrument underreads. If we have static tube leakage, the instrument overreads. And then instrument error is nothing but manufacturing error. And position error. Position error increases with angle of attack and decreases with speed. Position error we'll be having position error during high angle of attack and low speed. Now we also have density error. For density error, as we already seen that ASI reads only near MSL, ISA conditions. What if the ASI reads above MSL? Then true airspeed will be greater than indicated airspeed. What if it reads below MSL? True airspeed is less than IAS, indicated airspeed. Along with the density, we also have tolerance limit. That is nothing but plus or minus 3% or 5 knots. And whichever is greater among them, I'll explain you. If your speed, for example, it is 100 knots, and let us take both the tolerance limits, plus or minus 3, let us add it. Let us assume we are climbing. So let us add plus 3%. For 100, 3% is nothing but 100 plus 3, 103 feet. And also let us add 5 knots. For 100 adding 5 knots, we'll be having 105 knots. So which among these is greater? 105 knots is greater. So we'll consider 105 speed. Let us take another example. Let us consider we are having 300 knots of airspeed. Let us take tolerance limit of 5 knots. Let us add 300 plus 5, 305. And 3% of 300 knots is 9 knots. Let us add 9 knots to 300. Then we'll be having 309 knots. So which one would be greater among these two? Of course, 309 knots speed is greater. So we'll take the tolerance limit here as plus 3%. Okay. Then we have compressibility error. Compressibility error occurs when true airspeed is greater than 300 knots, calibrated airspeed is greater than 200 knots, and Mach number is greater than 0.4 Mach. And we have finally maneuvering error. Maneuvering error is nothing but this is the error which occurs during our flight, during the aircraft is side slipping. During it is if we need to turn like this, but aircraft is turning more than it has to be. So this is called side slipping. If we have a blockage if the aircraft is side slipping towards the blockage error, assume that this side we have a blockage error and this side we have no blockage error for the aircraft. If the aircraft is turning towards the blockage error side, it overreads. Towards the open side, it underreads. This is a short notes which you can go through before the exam. It helps us a lot. And this is enough for the exam. Nothing extra is needed. See, I have drawn a diagram for you as well. Thank you. Thank you for watching.